here we go. So, basic graphs of secant and cosecant. This is our last topic. And here's the idea. I don't want to graph cosecant. I want to graph 1 over sine. What's the relationship between sine and cosecant? They're reciprocals. So, in order to get an idea of what this looks like, I'm going to make a graph of y equals sine of x first. So we're going to go back to the very basics. Okay? What's the biggest value that sine can be? What's the amplitude? 1. What's the smallest value that sine can be? -1. What's the period of sine? 2 pi. Any questions how I got that far? Where does sine start, the max, min, or middle? Is it going to start by going up or down? Up. That's the graph of sine. That's something we've seen before, right? If you're capable of doing that, then you can graph cosecant. And here's why. First of all, that graph is not the graph at all of cosecant, but it helps us get the graph of cosecant. This is what you have to follow right now with your brain. Otherwise, you're not going to get it. What is the height of the graph right here? 0. Sine is 0 right here. I don't want to graph sine. I want to graph cosecant. What's the relationship between cosecant and sine? Reciprocals. So I'm going to graph the reciprocal of 0. What's the reciprocal of 0? Which is undefined. So every time you see a spot where the sine graph crosses 0, you draw one of these things. Those that we learned yesterday are called vertical asymptotes. They are lines that the graph approaches. They're not actually part of the graph. It's what they approach. I still haven't drawn the graph of cosecant yet, but I'm going to right now. What is the height of my graph right here? 1. But I don't want to draw the graph of sine. I want to draw the graph of cosecant. So I need to take the reciprocal. What's the reciprocal of 1? 1. That's a spot that the graphs share in common. Now, watch this. I'm going to move over here. Am I at a really big value or a really small value? What's the reciprocal of a very small number? if I have a really small number, say 1 over 1,000, what's the reciprocal of a really small number? A really big number. So all we have to do, that's the reasoning behind it, is once you have this graph of sine, all you do is you put dots on the max or min, and you draw these U-shaped things out towards your asymptotes. So the only part of my graph that's actually the graph of cosecant is the red. But I use all the other parts to sketch the graph. So remember before where I told you if you know how to graph sine and cosine, you're going to be able to figure out how to do everything else. Well, do you see the sine graph here? That's why it's essential for us to be able to graph that in order to get the other graph. Now, if you're slightly confused, that's okay. We're going to clarify that right here. Instead of graphing secant, what do you think I graph? What's the reciprocal of secant? Cosine of x. What is the maximum value? Minimum value? What's the period? Where does cosine start? Max, min, or middle? It's going to start at the max in this situation. I still haven't graphed cosecant, or still haven't graphed secant, okay? I've just graphed cosine. What is the height right here? 0. What's the reciprocal of 0? So I draw vertical asymptotes wherever it goes through 0. After I do that, I just draw these U-shaped things at the max and mins. I'll bring it back up in a second. Hold on. So you might wonder how accurate that is. I go into here and I graph 1 divided by cosine. I'm in radians. I check my window. And my window, I'm going to start a minimum of negative 2 pi, a maximum of 2 pi, a scale of every pi divided by 2, a minimum, I'm going to go down to negative 2, a maximum, I'm going to go up to positive 2, and watch my graph. Does that look like the graph that I have there? You never thought you'd be able to graph something that difficult, did you? What's the graph that goes right through the middle? That's the graph of, what do we sketch right away? We sketch cosine. Watch this. This is really cool. Go over here, I'll make it. I'll make it dashed. Oh, come on, that's somewhat impressive, is it not? Darren's not impressed. All right, whatever. You're not impressive. All right. Okay, here we go. Yeah, we'll have math duel tomorrow. Okay, let's check it out. We'll skip through the notes and we'll go right to example 1, example 2. Okay, this is what I want to graph. I want to graph 2 cosecant. Instead of graphing 2 cosecant, I graph 2 sine. That will give me an idea of how the graph is going to look. So I'll start by graphing that. Okay, you tell me. Amplitude. 2. Period. 2 pi divided by the number in front of x. It's going to give me 2 pi. Okay. Now what? I'm trying to graph this. Where do I start? Then is that the graph of 2 cosecant? No, it's not the graph of 2 cosecant. What do I have to draw yet? Every time I cross a 0, I got to draw my vertical asymptotes. Now I'll draw the U things. So the black part is my actual graph. Looks super complicated, right? Like if you graph that and then your parents see it, you're like, holy cow, you're going to get a scholarship to Harvard because that's like some complex stuff. You're like, oh, this is no big thing. Like, it's just asymptotes and. Was it? For this one? Looks like we got 2 divided by, instead of cosine, we've got sine. And we're going to graph 2 sine. And what changes here in my window is that I want a y max of 4 and a y min of -4. And I'll have a tick mark every 2. A lot of times we do it, people are like, well, really, how accurate is it? Pretty good. Let's do one more. We're not going to do the complicated one. We'll keep it basic, okay? We'll do this one. Instead of graphing secant, what do I graph? I graph cosine. -3 cosine of 2x. What's the amplitude? What's period? Now what? Where do I start? Why do I start at the bottom? This is cosine. Cosine starts at the maximum because it's negative. I start at the bottom. Yes. Now what? Every time it crosses 0, I draw asymptotes. Now what? The U dudes. It's a cake upside down. All right, let's figure out an assignment. Okay, folks, there it is. There's your assignment, 11 through 14. It's just 4 problems. That's all I got. So what are we going to do tomorrow? Tomorrow, we're going to piece together all 6. So I'll be sitting here. You have no notes tomorrow, okay? What I will give to you is I will give to you a day to work on a worksheet that has you do all 6, okay? So raise your hand if you're not here tomorrow. You need that worksheet. Justito? All right, well, I'll get it.